Hi, today we'll be just revising the topic Pythagoras Theorem, and the introduction to this topic has already been done in your junior grades. So for class 10th, we will first revise the topic and then proceed to the proving questions on Pythagoras Theorem. So what exactly is the Pythagoras Theorem? The Pythagoras Theorem states that in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So, what does this mean? That if we have a red colored right angled triangle here, then if A and B are the legs of this triangle and C is the hypotenuse of this triangle, so A square plus B square is actually equals to C square. Now, geometrically, A square can be represented as the area of the square on side A. B square can be represented as the area of the square inscribed on side B, and C square is the area of the square described on side C. Right. Now let us see a visual proof of this. So let us see a visual proof of this topic here. So let us suppose that this is a right angled triangle. So the yellow one and the multicolored square here are the legs of this right angled triangle, and the longest side is the hypotenuse. Let us see, is the sum of these areas or these squares equal to the biggest one? Let's try. So if I just put this yellow one here and some pieces here, so just by overlapping and cutting and pasting, I've realized that the sum of these two squares is equal to the square of the bigger side here. So a square plus b square is equals to c square. Let us now reset this and try for some other right angled triangle. Okay, so let's take this as a right angled triangle. So I've changed the dimensions of the right angled triangle, and let me now match here. Now this square here, these four are congruent triangles. So I'm just placing them one by one, and we see that they completely add up together to make the biggest square here, right? Okay, let us try one more. Let's just do any other dimension. Okay, let's try this. So again, if we put all these together, it will be verified. So this actually holds true for all the right angled triangles. The only limitation is that all these triangles that we are discussing are right angled triangles. Okay, now let's come back to one more proof here. So there's an extension of this proof also that we can study, and this is a very beautiful visual proof that we have. Okay, now see, this actually holds true in the form of all the areas of regular polygons. So here we have seen these two pink squares add up to give the green square, and their areas are numerically mentioned also over here: 21.23, 65.43. When you add up both these areas, you get 44.226, right? So no, S1 plus green, these two add up to the pink, the greater pink here. So 21.23 is equal plus 44.23 equals to 65.43, right? So let's try, and I'm just changing something here. If you enlarge in this, it holds again true. Now using my slider, I'll just show, instead of taking a square on the legs, I'll now take another regular polygon that happens to be a regular pentagon. So this will also hold true for a pentagon. So these areas are all equal. The sum of these areas is